Hello students. So we were discussing about the ray optics topic. So let us continue with the same chapter. So here we have the question. Okay, so from here we need to continue. See, an object is placed at a distance of 20 centimeter from the pole of a concave mirror of focal length 10 centimeter. The distance of the image formed is. Here we need to calculate the distance of the image, means V value we have to calculate, and they have given the focal length value and the object distance. U value is, and here we need to calculate the image formed distance, that is V value. See how to do this. Here, as per the Cartesian sign convention, here the object distance is taken as negative because it is again for the focal length. For a concave mirror, the focal length value is also taken as negative. So therefore, F is equal to, it is minus 10 centimeter. Then next, we have the mirror formula. So substitute in the mirror formula. So the mirror formula is given by 1 by U plus 1 by V is equal to 1 divided by F. So from this you can calculate easily the value of the object distance, that sorry, the image distance V value. Okay. Yes, now hope so this is clearly audible to you. Okay, so from the formula, you can calculate the value of the image distance. The image distance is V is equal to, that is minus 20 centimeters. Yes, so now the image distance will be minus 20 centimeters. So here you can see the simplification, that is in the formula we need V value, therefore keep 1 by V, then this is 1 by F minus 1 divided by U. Substitute the F value, here you can see the substitution, 1 divided by minus 10 minus 1 divided by minus 20. Okay, so you can simplify this. And you will get the answer. If any doubt is there in the question, you can ask. Otherwise, we will go for the next question. Yes, completed students. Is it audible now clearly? Okay, let us go for the next question. See, a candle is placed at 25 centimeter from a lens, forms an image on a screen which is placed at 75 centimeter on the other side of the lens. The focal length and the type of the lens should be. So here a candle is placed at 25 centimeter from a lens. So this is the object distance. Candle is the object. From the lens, this is placed at 25 centimeter. It forms on the screen. The image is placed at 75 centimeter. Here we need to calculate the value of the focal length. Okay, so from the value of the focal length, we can understand which type of the lens is this. Can you try this? We can use the same formula. So lens formula we have to use. That is 1 by V minus 1 by F is 1 by V minus 1 by U is equal to 1 by F. Yes. So according to the sign convention, it is here the object distance according to sign convention, left side of the mirror, sorry, the lens, therefore it is minus 25 centimeter. The image distance. So as the image is the real image, because screen mel kanasta ide image. So ad real image agatte. When it is a real, you have to consider the image distance plus 75 centimeter. Then the lens formula is 1 by F is equal to 1 by V minus 1 by. So again, substitute the formula. You have to simplify it for F is equal to. So answer will be plus 18.75 centimeter. So as the answer, we are getting it as positive. F value is positive. The lens is a convex lens. Yes, completed. Yes, the next question. This is for the prism formula. See here. The refracting angle of a prism is A and the refractive index material of the prism is cot of A by 2. Okay, the angle of minimum deviation. So the value of the angle of minimum deviation. So here given is this, the refracting angle of a angle is given as, and refractive the angle of the prism is A, refractive index is taken as cot of A by this cot A. What is the value of minimum deviation? Yes, how to do this? Completed the question? See here. As we know that according to the prism formula, the formula is what? That is the refractive index is equal to sine of A plus delta m by 2, this whole divided by sine of A by 2, sine of A by 2. Okay, the refractive index in the question, it is specified as cot of A by 2. It is given as cot of A by 2, which is equal to sine of A plus delta m by 2. This is angle of minimum deviation. And here it is sine of A divided by 2. Okay. So now we can just transfer this one. So cot can be written as cos upon sine. And that A by 2 is angle is A by 2. Then next here this sine, if I take transfer on the other side, it comes in the numerator. So sine of A by 2, which is equal to. So which is equal to, this is sine of A plus delta m divided by 2. So sine of A by 2, sine of A by 2 will get cancelled. So here we have cos and here we have sine. So to simplify this, cos and sine convert madana. So if I want to convert it, this will be sine of 90 minus theta. So that is pi by 2 minus A by 2 is equal to sine of A plus delta m by 2. Okay, so sine inverse, we can cancel on both the side. Therefore, the further simplification here you can see, students. So pi by 2, we can cancel this one. So pi by 2 minus A by 2 is equal to A by 2 plus delta m by 2. Okay, so we require only the angle of minimum deviation. So if I transfer this A by 2 on the other side, it will be minus A by 2. So minus A by 2 minus A by 2 will be minus 2A by 2. 2 will get cancelled. So here we have pi by 2 minus A. So further it will be pi minus 2A, which is equal to that is delta m. So delta m is the angle of minimum deviation. So this will be 180 degree minus 2a, which is equal to delta m. But in YouTube, it is showing clear, audible. Little you also change your place. Let's see the next question. Now, is it audible, students? Is it audible now? Yes, Amulya. ಈಗ ಕೇಳಿಸ್ತಾ ಇದೆಯಾ? Okay. Yes. Okay, let us continue with the next question. See, an object approaches a convergent lens from the left of the lens with a uniform speed 5 meters per second and stops at the focus, the image. So what happens to the image? See the question here. See what they are saying here. That is, an object approaches a convergent lens. So here you have a convergent lens. Okay, so from the left of the lenses, so convergent lenses, divergent lenses we will be having. So this is concave lens, this is the convex lens. So which one is the convergent lens, students? Which one is called as the convergent lens? Yes, convex lenses, that is, this one is called as the convergent lenses. So here what they are saying in the question, that is, for the convergent lens from the left side. Okay, so from the left side of the lens with a uniform speed, an object is approaching. So that speed of the object is given as how much? 5 meters per second and stops at the focus. So this object stops at the focus. The image, so what will be the image? You can see here, moves away from the lens with a non-uniform acceleration, moves towards the lens with a non-uniform acceleration, moves away from the lens with an uniform speed of 5 meters per second, moves away from the lens with an uniform acceleration. Yes, which option is right here? So what happens to the image when the object is moving with a speed of 5 meters per second. Yes, so the answer will be, that is, when the object is approaching at the speed of 5 meters per second towards the lens, the image moves away from the lens with a non-uniform acceleration. So option A is the right answer. Okay, so here you can see in the 2020 this question is asked. See the next question. In refraction, light waves are bent on passing from one medium to the second medium, because in the second medium, yes, so this is based on the refraction phenomena, what they're asking here. So in the refraction, the light waves are bent. So as you know that refraction is nothing but what? When the light waves are incidenting on the surface, here it will change the direction of the propagation. This phenomena is called as what? That is the refraction. This phenomena is called as refraction. Okay, so this is the first medium and this is the second medium. Here what they are asking here, the direction of the light rays changes. What will be the reason for that? What is the reason for the change in the direction in case of the refraction phenomena? Yes, so here the options are, that is, the frequency is different, speed is different, coefficient of elasticity is different, amplitude is smaller. So according to the option, means the medium 1 and medium 2 are having different frequencies, both the mediums are having the different speed, or the coefficient of elasticity is different here, or the amplitude values are different. Which is the answer? This question is clear to you? See, here, what is the reason here? That is, the speed is different. So here, when the light is traveling from one medium to other medium, here the speed, as the light travels from one medium to other medium, speed of light changes, and this results in the bending of light, and the phenomena is called as what? Refraction of light. Okay, the next question. If the refractive index from air to glass is 3/2 and from air to water is 4/3. So here what they are saying in the question, that is, the refractive index is given. So the refractive index of air to glass is given as 3/2, and that of the refractive index of air to water is how much? It is 4/3. Then the ratio of the focal length of the glass lens in water and in air is. So here they are asking the ratio of the focal length of glass lens in water, glass lens in water and in air is. The ratios are given as 1:2, 2:1, 1:4, 4:1. Yes. See how to simplify this one. So as we know that according to the lens maker's formula, here we can substitute. See, according to lens maker's formula, this is 1/f is equal to the relative refractive index mu0 upon mu1 minus 1 into the radius of curvature. Okay, so here the value of the refractive index, it is given. So now this general formula, we are writing it first one for the glass in water. So first we are writing it for glass in water. So for the glass in water, it is written as 1/f focal length in water into bracket the refractive index of glass divided by the refractive index of water minus 1 into bracket 1 divided by R1 minus 1 divided by R2. So now this is glass in water. Similarly, glass in air. The formula is written as 1/FA is equal to, because for air the refractive index is 1. So this is refractive index of glass minus 1 into bracket 1 divided by R1 minus 1 divided by R2. You can name these equations as equation 1 and 2. You can take the ratio and simplification. You can try this one. Yes, so this is equation 1, equation 2. So dividing equation 2 by 1, dividing equation 2 divided by 1. Yes. So when you divide 2 by 1, you can see here, whatever this 1 by R1 minus 1 by R2 is there, this terms will get cancelled. When you take the ratio, these terms will get cancelled. So remaining, we will have only this one. And the refractive index of all the glass water is given in the question. So the ratio will be 4:1. Option D is the answer. You can copy down the solution. Okay, completed. So next questions we will take. Just a minute. Okay, see the next question. Yes. See here, the refracting angle of a prism is 60°. It produces a deviation of 30°. When placed in the position of minimum deviation, the angle of incidence is. So what is the angle of incidence they are asking? Here the angle of minimum deviation is given and the refracting angle A value is given. So angle of incidence we have to calculate. Copied on the question, we will do this one. Yes. So as we know that the relation between the angle of the incidence and the angle of deviation is given by I is equal to delta m plus a divided by 2. Okay, so angle of minimum deviation is there, a value is there, therefore ai is equal to, so this is 60 plus 30 divided by 2. So 60 plus 30 will be, that is 90, 90 by 2 will be 45. So therefore option C is the answer. Okay, copy down and let us see the next question. Is the next question. The angle of prism is 60 degree. If the refracted ray passes parallel to the base of the prism, the angle of refraction inside the prism is, so what is the value of the angle of refraction inside the prism? Here the values, a value is given if the refracted ray passes parallel to the base of the prism. So the angle of refraction, R value we have to calculate. Yes. So as we know that, that is A is equal to, that is the relation between R and A is, R is equal to A divided by 2. So A value is 60 degrees. So it is 60 divided by 2 means this is 30 degree. That is option B is the answer. So these formulas we are writing it from the prism formula derivation. Okay. So prism formula derivation alli navidein middle steps in baratte. Adralli we have I is equal to, that is a plus delta m by 2, right? And r is equal to a by 2. These all steps we will get it in the derivation. So from there we are using that one here directly. So next question here, students, that is the, for a glass prism, here the angle of refractive index is given for the glass prism as 1.6. The angle of minimum deviation is equal to the angle of the prism. Okay. So here what they have given, so for the glass prism, the angle of minimum deviation is equal to the angle of the prism, they are saying. So angle of minimum deviation is taken as, that is delta m, and angle of the prism is taken as A. Then the angle of the prism is approximately. So what is the value of the angle of the prism? Yes, the angle of the prism. What will be the angle of the prism? The refractive index is given as 1.6. How to do this? Yes, what is the answer? They have given hint only the refractive index value. And they have specified that both are equal. Angle of minimum deviation and this one is equal. Yes. See how to solve this here, students. That is, see, in the question they have given angle of minimum deviation is equal to the angle of the prism. So we have the formula. The refractive index is equal to sine of, this is a plus delta m by 2, and this is sine of a by 2. Okay. So this is equal to, here what they are saying, both are equal. Therefore, I can also write it as what? That is sine of a plus a. A plus a will be 2a by 2. So this is 2a by 2 and this is sine of a by 2. Okay. So what we can do here? So this 2 we can cancel. Right? A by 2 cancel ಮಾಡಿದ್ರೆ sine of 2 we will have. So again answer ಬರಲ್ಲ ಅಲ್ಲಿ. And the mu value is given. The refractive index is given as 1.6. Okay. So now here we have the next step will be 1.6 is equal to, this is sine of a upon sine of a by 2. Sine of a divided by sine of a by 2. Okay. So this sine A, we can apply the half angle formula here. So sine 2 theta will be 2 into sine theta into cos theta. So similarly, we can write it as half angle formula. This will be 2 of 2 sine of A by 2 into cos of A by 2. And here this is denominator is sine of A by 2. So sine of A by 2, sine of A by 2 will get cancelled. This is 1.6 is equal to 2 into cos of A by 2. Right? So we require only the A value. Yes, next what we can do here, students? So that is, we have 1.6 is equal to 2 cos of A divided by 2. So this 2 we can transfer there. It will come in the denominator and we will have cos of A by 2. So 1.6 divided by 2 will be 0.8. So this 0.8 is equal to cos of A by 2. So further we can write it as cos inverse of 0.8 is equal to A by 2. But we require cos inverse value here. Yes, the cos inverse of 0.8 will be, this is 0. Okay, if you have the log table, you can just check, students, later. Right now, I don't have live log table. So cos inverse of 0.8 you check. So whatever the answer you will get, multiply it by 2, then A is equal to, that will be your final answer. Okay. So you can check it later. Yes, copy down. So this one later you check it in the log table. Let us go for the next question. See the next question. The angle of prism is 30 degree. A ray incident at 60 degree on one of the refracting surfaces suffers a deviation of 30 degree. The angle of emergence is, so what is the angle of emergence? Can you try this? See how to do this one. Here the angle of prism is given as 30 degree. And the ray is incidenting at 60 degree on one of the refracting surface. And the suffers a deviation of 30 degree. We need to calculate the angle of emergence. See here, that is A value is given in the question. The A value is, it is given as 30 degree. Okay, then the deviation is given as, the angle of the prism is 30 degree. Deviation is given as 30 degree. And the angle of incidence is given as 60 degree. So as we know that the angle of minimum deviation is equal to I plus E minus A. So we require the value of the E value. So remaining values we can just transfer that. So here this is 30 is equal to, this is 60 plus E. And this is minus of 30 degree. So this 30, if I shift, it will be plus 30. So here it will become 60, which is equal to 60 plus E. So 60, if I transfer, the answer will be 0. The angle of emergence will be 0. That is, option D is the right answer. Okay. Last question for today's class. See the last question. A thin prism of angle 10 degree. So the thin prism of angle is given as 10 degree and the refractive index is given as 1.5 is combined with another prism of angle theta. So another prism is there whose angle is taken as theta and its refractive index is given as 1.7. If the emergent ray passes undeviated, so the emergent ray means what? This is the incident ray, this is refracted ray, this is the emergent ray. So what they are saying, if the emergent ray passes undeviated, okay, so it goes undeviated, then the angle theta of the second prism is, this how to do this. Yes, see how to do this one. They are asking you, if the emergent ray passes undeviated, then the angle theta of the second prism. Yes, how to do this one, students? Here the refractive index is given as 1.7 and the angle of the prism A is given as 10 degree. Refractive index, one is 1.5 and the other one is 1.7. Yes. So see here how to do this one. So let us consider A1 as the refractive index of the first prism, and that is given as 10 degree. And for that, the refractive index value, it is given as 1.5. Okay, the refractive index of the second prism is given as 1.7. Okay, here we need to calculate the value of the A2, that is the angle of prism of the second prism. Okay, so as we know that the angle of deviation is equal to, that is mu minus 1 into A. And we also know that, so this is equation 1, and we also know that here when we have the two prism, the total deviation is 0. The total deviation will be 0. So therefore what we can write here? We can write here as what? Delta 1 is equal to delta 2. The deviation of the first prism is equal to the deviation of the second prism. So therefore the equation 1 can be written as, so delta 1 is equal to delta 2. Hagadre naವೇನು ಬರಿಬಹುದು? That is mu 1 minus 1 into A1 is equal to mu 2 minus 1 into A2, right? So that is mu 1 minus 1 into A1 is equal to mu 2 minus 1 into A2, right? So now here mu 1 value, mu 2 values both are there. A1 value is there, only A2 value we need to check. You can try the simplification. So mu 1 minus 1. So mu 1 minus 1 is how much? 1.5 minus 1 will be 0.5. So this is 0.5 into 10 is equal to, and this is 1.7 minus 1 will be 0.7 into A2. Check how much you will get the answer. So here the answer will be 7.14, the approximately 7 degree we can consider, students. So 0.5 into 5 will be, this is 10. So 10 divided by 0.7 is equal to, this is A2. So 10 divided by 0.7 will be, it is 7.142. So approximately we can take it as 7 degree. Option A is the right answer. Okay, option A is the right answer. Okay, so this completes question on the ray optics. If any doubt is there in the chapter, you can ask. Yes, any doubt in the solved questions or anything? Okay, so we will meet in the next class with the next topic. Thank you.